I'm going to work through a few factoring problems and others as well from the Math 3 Unit 3 Worksheet 5, starting with number 6. Number 6, we need to look at these three terms that I'm underlining and ask ourselves, what can we divide all three by? All of them have an r plus s. So we divide each one by r plus s, and what's left is an a minus b plus c. And it's factored. Number 8, look at the first two terms. The ones I'm underlining, they both have a 2c minus d. Well, actually they don't. They almost do. One is 2c minus d, the other one is d minus 2c. So if you, so I'm looking at these two pieces here. If you have this where they're not quite the same, they're actually opposites of each other. So one is a positive 2c, the other one has a negative 2c. One has a negative d, the other one has a positive d. You can make them alike by factoring out a negative sign. So what I mean is I could rewrite the first part, and I could, you can think of it as either, I'll factor out a negative. So if I make this a negative x squared, that means I need to change the signs of what's in here, make it a negative d and a positive 2c. Now, although they're not written in the same order, now they match. They both have a positive 2c and a negative d. And so I can divide both of them by 2c minus d. And what's left is a 9 minus x squared. The 9 minus x squared is the difference of two squares, so I can factor that as well. To 3 plus x times 3 minus x. Number 12, the first two terms. If you have four terms, you try factoring by grouping, and that's what I'm doing. I'm looking at the first two terms. I can factor a 3w squared out, and I'm left with w minus z. Look at the next two terms, or the last two terms, and I could factor out a 18w, and I'm left with a w minus z. Both of these terms have a w minus z. And so if you divide them both by w minus z, you end up with 3w squared plus 18w. And if you look at my second factor, the 3w squared plus 18w, you could factor a 3w out of that. I'm going to switch things around so it doesn't get too confusing for you if you're watching. So I'm going to just rearrange my two factors. And the first factor, I'm going to factor a 3w out, and I end up with w plus 6, and w minus z still there, and that is completely factored now. I could have also initially looked at all four terms and divided all of them by 3w to start with, and then factored by grouping. Either way, we want to end up here. Number 18, we're asked to factor and sketch the polynomial function, label any x and y-intercepts. We've got four terms. I'm going to try factoring by grouping. So the first two terms I could divide by 3x squared, and I'm left with x plus 3. The last two terms I could divide by negative 9x. Sorry, negative 9. No. I'm looking at the wrong two terms here. The 27 and 81 are both divisible by 27. So I'm going to factor out a negative 27, and I'm left with x plus 3 again. Then you divide each of these pieces by x plus 3, and you get f of x equals x plus 3 times 3x squared minus 27. That 3x squared minus 27, you can divide both of those by 3. I'm going to move that 3 way up front, but it came out of the 3x squared. And if you divide each of those by 3, you end up with x squared minus 9. And then the x squared minus 9 you can factor further to x plus 3 times x minus 3. Now each factor with a variable gives you an x-intercept, each linear factor. The 3 is not going to contribute to our x-intercept. So, but the x minus 3, if we set that, x plus 3, set that equal to 0, you get x is negative 3. This one is going to give you the same answer. So we have a double root here, or have a multiplicity of 2. So at negative 3, we know it's going to bounce. And when x minus 3 is equal to 0, we get x equals positive 3. There's only one of those, an odd multiplicity, so it's going to pass through. Here we're going to find our y-intercept. So you plug in 0 for x, and you get y, or f of x, equals 3 times 0 plus 3 times 0 plus 3 times 0 minus 3. And plugging it into this, this bottom one here, which gives you 3 times 3 times 3 times negative 3, or negative 81. Probably an easier way to do this is if you plug in x equals 0 into the original function, because you could see the first 3 terms would 0 out and you'd end up with negative 81. But either way, we want a y-intercept at 0, negative 81. So that's way down here. Alright, so now let's sketch our graph. We know it needs to go through the y-intercept and reach those x-intercepts. It's going to pass through the one on the right, so it just keeps going up, and it's going to bounce on the one on the left, so it goes back down, and there we have it. We didn't even have to consider the end behavior, but we can check that. We have a, if you look at the original, it's in standard form, so easier to work with. We see we have a positive leading coefficient, that's our 3 there, so that makes the right end point up. And the degree is odd, which makes the left end go in the opposite direction, and our graph does. Next, let's look at 20. 20, we want y equals f of x, which is 4x to the 4th plus 8x cubed minus g of x, which is 16x squared plus 32x. Make sure you put that second piece in parentheses because we need to distribute the negative. And we get y equals 4x to the 4th plus 8x to the 3rd minus 16x squared minus 32x. We got 4 terms. We can factor by grouping, but I'm going to do what I didn't do the last 2 times. Is I'm going to look at all 4 terms this time and factor out the greatest common factor. So all of them are divisible by 4x, and when I divide them all by 4x, I end up with x to the 3rd plus 2x squared minus 4x minus 8. Then I'm going to try to factor the 4 terms. So now we have y equals 4x times, divide the first two terms by x squared, and you get x plus 2. And divide the last two terms by negative 4, and you get another x plus 2. And so now y is 4x. Divide each of those pieces by x plus 2, so times x plus 2 times x squared minus 4. And that x squared minus 4 is a difference of two squares, which is x plus 2 times x minus 2. So here we have x is 0. There's only one of them, that's your x-intercept and your y-intercept, and it's going to pass through that one. We have 2 of the x plus 2, so we get x plus 2 is 0, and that gives us x equals negative 2, and we get another one, x equals negative 2. So we have a multiplicity of 2 at negative 2, so it's going to bounce at that point, because the multiplicity is even. And the last one, when x minus 2 is 0, we get x is 2, and there's only one of those, so the multiplicity is odd, so it's going to pass through that one as well. We're not sure what's happening with the end behavior, so I'm going to take a look at our leading coefficient, which when it was in standard form, I'm going to highlight standard form here. You can just look back at that one, and we can see our leading coefficient is positive 4. So it's positive, which tells us the right end points up. So right end points up, it's going to pass through at 2, it's going to pass through at 0, and then when it hits negative 2, it's going to bounce back up. And if you notice, the degree is even, it's 4, so both ends are pointing in the same direction. And we'll stop there.